Millions of people have been taking GLP-1 medications for weight loss for the past several years and have seen amazing results. You may be one of those people. Celebrities like Serena Williams, Charles Barkley, and Oprah have been transparent about taking these medications to achieve a slimmer figure. But what isn't being talked about is what happens after people stop taking them. Do they keep the weight off, or do they basically need to inject themselves for the rest of their lives in order to maintain their goal weight, essentially becoming medication dependent? Whether or not you or someone you know is on a GLP-1, this question matters because these medications, like all medications, have a cost. Also, it is important to study what happens after treatment in order to understand if GLP-1 medications are actually a long-term solution or just a band-aid for the obesity epidemic. Together, let's see what the data have to say. As always, let's start with a little background. What are GLP-1s? GLP-1 stands for glucagon-like peptide 1, which is a hormone that our bodies already produce naturally in response to food. The GLP-1 that our bodies make gets broken down very rapidly, however, in a matter of minutes, while injectable synthetic GLP-1s have a much longer half-life, ranging from hours to up to about a week. Because they take much longer to be cleared out of our system, their effects are more powerful. The class of GLP-1 medications can refer to medications that contain GLP-1 receptor agonists, which I will just refer to as GLP-1s moving forward, alone or in combination with other substances. For example, semaglutide, sold as Ozempic and Wegovy, contains just GLP-1, while tirzepatide, sold as Monjauro and Zepbound, contains GLP-1 in combination with a gastric inhibitory polypeptide or GIP analog. You can think of an analog as a lab-made version of what our bodies already make. GIP is a hormone that our bodies produce in response to food, which, like GLP-1, can stimulate insulin secretion and lower blood sugar. Fun fact, we wouldn't have all of these injectable GLP-1 medications if it weren't for the Gila monster and the work of a determined scientist by the name of Dr. John Eng. Way back in the 1990s, Dr. Eng discovered that Gila monster venom contained a hormone that works similarly to the GLP-1 that our human bodies produce, but that it lasts way longer in the blood. Remember, natural GLP-1 gets broken down in mere minutes. However, this similar hormone in Gila monster venom, Exendin 4, lasts hours. Scientists found a way to make this Gila monster hormone synthetically, labeling the synthetic hormone Exenide, and they received FDA approval in 2005 and sold it under the trade name Byetta, among others, for diabetes treatment. Byetta is administered as a twice-daily injection, while popular GLP-1s like Ozempic and Monjauro only need to be injected once a week, showing a really nice advancement in this scientific research that started out with a venomous lizard. Now, what does the data show with regards to the effectiveness of GLP-1s for weight loss and other health conditions? The latest research on GLP-1s shows that they are capable of helping people to lose anywhere between 5 and up to 21% of their total body weight after anywhere between 36 weeks and 72 weeks of treatment, which is amazing. Many people are focused on the aesthetics of weight loss and like to see those numbers for that reason, which is fine, but I want to add another important reason why this amount of weight loss is so significant. These medications are improving people's biomarkers of health and therefore making them healthier overall and potentially extending their lifespans. GLP-1s have been shown to be effective at reducing hemoglobin A1C, a number that is very important for people with diabetes because it represents your average blood sugar levels over the course of 2 to 3 months, fasting glucose, aka blood sugar, fasting insulin, systolic and diastolic blood pressure, cholesterol, triglycerides, and waist circumference. These medications have been approved by the FDA for heart disease-related death, heart attack and or stroke, weight management, metabolic-associated steatohepatitis, informally known as fatty liver, type 2 diabetes, chronic kidney disease, and obstructive sleep apnea. These medications work mainly by helping people to eat less. Studies show that GLP-1s can lower total calorie intake by 16 to 39%. People taking GLP-1s report having less cravings, fewer episodes of binge eating, and less food noise or thoughts about food overall. What's really nice about GLP-1s is that they produce minor, if any, side effects for most people. Nausea, abdominal pain, vomiting, constipation, and diarrhea are among the most common, and they usually present themselves during the first few weeks of starting a GLP-1 when the body is still getting used to the medication. There is also some evidence that in rare cases, GLP-1s may potentially increase the risk of thyroid cancer, although there are studies which have found found no association for this as well. More research is needed on this topic. So we know that these medications are effective at helping people to lose weight, improve their health overall, and that they're generally safe and well tolerated. Now let's get into the meat of today's video. What happens after people achieve weight loss and then stop taking that GLP-1 medication? The answer is a bit disheartening, but perhaps not all that surprising. Many people regain the weight that they lost. Let's take a closer look. In this study of what happens after people stop taking semaglutide, aka Ozempic and Wegovy, researchers found that after 68 weeks on semaglutide, people lost 17.3% of their body weight. At this point, the medication was stopped and a subset of these people were followed for another year, during which they regained about 11.6% of their body weight. In other words, they regained 67% of the weight that they had lost after just 1 year. Now, on a positive note, that still represents a net weight loss after 1 year, but still that amount of weight regain is a bit concerning. Here is another study on what happens after people stop taking semaglutide. After losing 10.6% of their body weight over the course of 20 weeks on this medication. At this point, half of the study participants stopped the medication and were followed for a year. And after a year off the medication, they regained 6.9% of their body weight. That's 65% of the weight that they had lost. The other half of the participants continued to inject semaglutide and lost an additional 7.9% of their body weight. Now let's look at evidence for that other popular GLP-1, tirzepatide, aka Zepbound or Monjauro. In this study, 36 weeks on the highest tolerable dose of tirzepatide led to an average weight loss of 21%. At this point, half of the study participants continued to receive tirzepatide while the other half received a placebo. After a year of follow-up, those who stopped tirzepatide regained 14% of their body weight or 67% of the weight that they had lost. Liraglutide, also known as Victoza when used for diabetes treatment, and Saxenda when used for weight loss treatment, is another GLP-1 medication that has also been studied in this context. In this placebo-controlled trial of liraglutide, people lost an average of 8.4 kilograms of body weight after 56 weeks, but regained 3% of their body weight after just 12 weeks off of the GLP-1. Now, the final study that I'm going to present is actually not a clinical trial. This study pulled from data available from tens of thousands of hospitals and clinics in the United States that store patient records using the electronic health record system EPIC. Data from around 20,000 patients who took semaglutide and 18,000 patients who took liraglutide and stopped for a year was tracked in the patient's health records, and here is what they found. 1 year after stopping semaglutide, 44% of patients regained between 25 and 100% or more of the weight that they had lost while on the medication. In the case of liraglutide, that number was 45%. Now, that would suggest that over half of the patients were able to maintain their body weight or even continue to lose weight at that point, but the data is not that clear-cut. Take a look at this graph. On the vertical y-axis, you can see the percentage of patients. On the horizontal x-axis, you can see the months since stopping semaglutide. At the 12-month mark, 18% of people regained all the weight that they had lost, and in some cases even more than they had lost. 26% of people regained 25 to 99% of the weight that they had lost. 17% continued to lose weight, and 19% doubled their weight loss. So we have 18 plus 26 plus 17 plus 19, that's 80%. That leaves us with 20%, or a fifth of the patients in this gray area, which was designated as the maintenance category, but includes people who gained back up to 24% of the weight they lost. In other words, people who regained just under a quarter of the weight that they had lost were not counted along with the people who gained weight in the two orange categories above. Now, this makes some sense because we have to leave room for people's weight to fluctuate, but it does make it difficult to tell how many people truly did experience significant weight regain, because for some people, regaining 24% or 23 or 20% of their body weight is significant. The same is the case for the graph on liraglutide, where 21% of people are in this gray zone. All in all, the data does seem to show that about half of people regained the weight that they had lost on either semaglutide or liraglutide 1 year after stopping these medications. Looking at the glass as half full, however, this data does also tell us that close to half of people find success at maintaining their weight or continuing to lose weight. What I would have liked to have seen from this study is reporting on what made people who fell into the different categories different from one another. For example, did the people who succeeded at maintaining their weight loss or in even losing more weight exercise more? Did they at any point meet with a dietitian to get tailored diets? Did they continue taking non-GLP-1 weight loss medications? And this is something that I wonder about because I personally have worked with patients who have been on GLP-1s and then were prescribed an oral weight loss medication like phentermine or Contrave to help them to taper off of the GLP-1. Or I've also seen cases where their insurance stopped covering the GLP-1, so their doctors switched them to an oral weight loss medication. Based on how the data is presented, we really don't have a good way of knowing how many people who fell into the weight maintenance or weight loss category actually were on non-GLP-1 weight loss medications. So there's a lot more to explore here. But for now, let's focus on the people who experienced weight regain. Why does that happen? Why is rebound weight gain so common? Here's the thing about GLP-1 medications that I don't think gets talked about enough, and that is the fact that they were never meant to be standalone cures for obesity. These medications were always meant to be part of a broader health plan that includes things that won't surprise you: a healthy diet, exercise, and so forth. Without ongoing attention to these things, rebound weight gain is the likely result. And really, this is true for weight loss that is brought about by any mechanism, be it bariatric surgery, weight loss pills, any of those trendy diets that you find on Instagram. Without sustainable lifestyle habits, reversion to baseline is the logical end result. It has been estimated that on average, people regain 75% of the weight that they intentionally lose within 5 years. Still, if you were on a GLP-1 and then experienced rebound weight gain, I want you to know that it is not entirely your fault. That's because it's not just a lack of willpower or discipline that leads someone to gain weight. The fact of the matter is that our bodies often fight against us when we try to lose weight. And if you've ever tried to lose weight, you may have experienced this personally, where it feels like your body is resisting any attempt that you have to lose weight, and it's doing its best to hold on to every ounce of fat. It's not just in your head, there are mechanisms behind this. Our bodies may push us to regain weight in several ways, including through gut hormones and brain systems for controlling food intake via homeostasis or balance mechanisms and reward pathways. I'll add to that list changes in body composition and adaptive thermogenesis. I'll define all of these shortly, but let's start with the first reason: how gut hormones may contribute to weight regain. Now, as part of our normal physiology, our bodies produce hormones that play a role in our levels of hunger and satiation and ultimately determine our weight. There are hormones that promote hunger, such as ghrelin, which is produced in the stomach, and hormones that suppress hunger, such as peptide tyrosine that is produced in our intestines, and leptin, which is produced by our fat cells. GLP-1 also helps to suppress hunger and is produced in our intestines as well. These hormones send signals to the hypothalamus, which is a part of the brain that helps us to regulate energy balance and therefore body weight. This is part of how GLP-1 medications work, by the way. They stimulate receptors in the hypothalamus and help to reduce food intake and thereby reduce body weight. Now, generally speaking, the amount of these hormones circulating in our blood is going to be dependent on how long it's been since we've had a meal. So if you are due for a meal, your ghrelin is likely to be high. If you have just eaten, your peptide tyrosine is likely to be high. However, when you compare hormone levels between human beings, you will see that, like with everything in this world, there is some variation. There is a theory that obesity, which is a multifactorial health condition, is due, at least in part, to a disruption or dysregulation of the body's homeostatic or balance mechanisms for keeping those hormones in balance and therefore maintaining a healthy body weight. Some studies show that GLP-1 production might be lowered in people with obesity after a meal. However, the data is mixed. There is some research showing the opposite effect, so more research in this arena is needed. Research findings also suggest that even if people with obesity produce normal levels of the satiety hormone GLP-1, their bodies may have a sort of resistance to it. If this were true, people with obesity would find food to be less satiating and be more prone to overconsumption of calories and weight gain. Ghrelin, a hunger hormone, has also been shown to be correlated with stress. Sudden exposure to any type of stress, be it physical or mental, may cause a spike in ghrelin levels. What's interesting though is that people who are overweight or obese have been shown to produce a sharper and more prolonged increase in ghrelin in response to a short-term stressor. While more research is needed to determine if there's a causal link between this rise in ghrelin and people's behaviors, it wouldn't be unreasonable to hypothesize that this increase in ghrelin could lead to more stress eating in people who are overweight or obese. Having more stress in one's life in general has been associated with a higher intake of calories, poor diet quality, and a higher likelihood of being obese. Now, the hormones that are involved in helping to keep our body weight at a certain set point are also involved in our brain's reward systems. Eating is something that we have to do in order to extract energy from food and keep on living and reproducing. So it's no surprise that nature has also found a way to make it pleasurable. If you're like most people, you have experienced the rush of eating a nice piece of chocolate or a good plate of food. That is your body rewarding you for putting calories into it. We experience this reward via the mesolimbic reward system. This system is located in the brain and involves neurons or brain cells in a region called the ventral tegmental area, or VTA, that release dopamine into various other parts of the brain that are responsible for memory, emotional regulation, and decision making. GLP-1s have the capacity to inhibit the firing of neurons in the VTA and thereby stop the activation of this reward system. In this way, GLP-1s can reduce that drive to eat beyond what is necessary that so many people feel by dampening the dopamine release and therefore reducing that reward effect that one would get from doing that. This reduction in the drive to just eat for pleasure is something that I've heard from my patients as well. People can go from only thinking about food all day to even forgetting to eat enough calories. It's pretty amazing. Nevertheless, people may find that once they stop the GLP-1 and there's less GLP-1 circulating in their system, that food noise comes back along with the habits that led to weight gain in the first place. So that pretty much covers how gut hormones like GLP-1 can help to regulate body weight through our body's balance or homeostatic mechanisms and reward systems located in the brain. You might also be curious to know if weight loss or gain can change the amount of gut hormones that your body produces. To summarize, the association between satiety hormones in our blood, hunger, and consequent weight gain is not entirely clear-cut. There are studies which show that these hormones shift in response to weight loss to promote weight gain, others which show that they shift to promote weight maintenance, and others still which show that there is no single predictive effect of gut hormones on hunger levels after weight loss. Ultimately, a lot more research on this topic is needed to really understand how weight gain and weight loss in the short term and long term can affect the production of gut hormones. Next, let's talk about body composition and adaptive thermogenesis. Your body composition basically describes how your body mass is divided between fat mass and lean mass, which is everything that is not fat, including muscle, organs, bones, etc. Athletes tend to have a very low percentage of body fat and high percentage of lean body mass from muscle, which gives them a more chiseled look, depending on the sport. Now, it has been theorized that repeated cycles of weight loss and then gain and then loss again, what we commonly call yo-yo dieting, can lead people to mess up their metabolisms by negatively impacting their body composition. The rationale is that assuming that people are not exercising enough and getting enough protein during weight loss, that they might end up losing a larger fraction of muscle mass and gaining a larger fraction of fat mass. This loss of highly metabolically active muscle mass can lead to a lower basal metabolic rate, which is a measure of how many calories you burn just by existing. This in turn can make it harder to maintain a lower body weight, as you would be burning less calories than you did before the weight gain, even though you're seeing the same number on the scale. Clinical trial evidence is mixed, however. There are studies showing no change in basal metabolic rate after repeated cycles of weight loss and regain, while more recent studies show that weight cycling may lead people to burn fewer calories. People who are already within the normal weight range and/or elderly are more likely to experience excess regain of fat mass during weight regain after weight loss. This reduction in calories burned post-weight loss is known as adaptive thermogenesis and can represent a significant roadblock for for people who are trying to continue lose weight or maintain the weight that they worked so hard to lose. In essence, the body adjusts its metabolism in order to burn fewer calories and keep itself at a certain set weight. Some research shows that this metabolic adaptation can last for over a year, while others show that once people exit their weight loss phase and enter their weight maintenance phase, this adaptation might go away. Interestingly, our bodies may not only adjust the amount of calories burned after weight loss, they may also adjust the type of calories burned. And this is yet another stumbling block that people who are trying to lose weight and maintain weight loss may run into. Here's what can happen. We can get energy from many sources. Carbohydrates, protein, and fat can all be converted into adenosine triphosphate or ATP, the primary energy molecule in our bodies. Our bodies don't just depend on what we ate that day for energy though. They also store molecules to be used for energy later on. The fact that our bodies store fat is one very obvious example. Now, when it comes to actually using that fat for energy, there is quite a bit of variation from person to person in terms of how efficiently this process is carried out. Some people's bodies pull from stores of fat at a high rate, so those people burn fat more quickly, while other people's bodies pull from their fat stores at a lower rate. For that second category of people, which I'm sure includes some of you watching, losing weight and keeping it off can be more of a challenge. Some research shows that in people who have lost a lot of weight, the rate at which the body burns fat for energy is lower than it is for people who have not gone through a weight loss journey. In other words, two people can be the same weight, but if one of them has a history of being overweight in the past and they had to lose weight to get to the weight that they're at today, then that person's body is likely to burn less fat than the person without a history of being overweight. In people who are obese, fat burning is likely to be reduced by several mechanisms. One is insulin resistance, which is associated with a reduced expression of adipose triglyceride lipase, which is an enzyme that is responsible for burning fat when we are going about our normal day-to-day activities. Another potential cause is the impairment of different receptors that are on our cells, such as adrenoceptors. These receptors are part of the sympathetic nervous system and can promote fat burning under normal conditions when stimulated by catecholamines, which are signaling molecules released by cells, one example being epinephrine. However, in people with obesity, the adrenoceptors that are supposed to help us burn fat stop working properly. A third reason why fat burning is reduced in people with obesity is the reduced expression of hormone-sensitive lipase, which is an enzyme that plays a critical role in fat burning. So again, if you have ever tried to lose weight or you're on a weight loss journey right now and you feel like your body is fighting against you to keep that extra weight on, it is not just in your head. There are physiological mechanisms behind what you're feeling. What is hopeful about all of this though is that there is at least some data which shows that some of these adaptations may be temporary, so you won't feel like you're on the struggle bus forever. You just have to keep pushing through. All right, so that covers the science. Now let's get into my recommendations. If you're on a GLP-1 and you eventually want to get off of it without regaining weight, what should you do? The first thing I want to say in this regard is to not be afraid to use the medication in the first place. I've seen a lot of people online saying things like, oh, it's a crutch, it's a cheat. Ignore them. As a dietitian, my stance is that these medications can be very effective at helping people to lose weight and improve their health in the myriad ways that I covered at the top of this video. A reduced risk of stroke, better control of blood sugar, better control of sleep apnea, chronic kidney disease, and the list goes on and on. But if you're not trying to be on these medications forever, and the first thing that you want to do is make sure that you really examine your diet. I have had countless patients on GLP-1s tell me that they have so little appetite that they can go all day without eating, and they do exactly that. This is very dangerous in the long run because you can end up with a number of different nutritional deficiencies that can cause symptoms like hair loss, fatigue, muscle weakness, bruising or wounds that won't heal, itchiness, dry and flaky skin, and so on. If you have access to a dietitian, I would suggest that you meet with them at least once to get an idea of how many calories you're actually supposed to be having and the ideal macronutrient distribution for your age, gender, activity level, and overall lifestyle. Also, you should make sure that you are prioritizing protein intake. Even if you have a very low appetite, make sure you get that protein in. This is because even if you don't eat enough protein, your body will pull from the existing protein stores to make sure that it keeps you alive and makes things like enzymes and hormones and antibodies, different cells in your body. So you really want to make sure that you're eating enough protein so you don't end up with an excessive loss of muscle mass. Next, I want to highlight the importance of lifestyle. Specifically, you should make sure that you have a stress management routine. As I mentioned before, stress is associated with weight gain. If you are somebody that has a tendency to reach for foods that are really sugary, fatty, salty, just calorically dense when you feel any sort of negative emotion, then this especially applies to you. Persistent stress can also negatively impact the quality of your sleep, which can lead to higher levels of the hunger hormone ghrelin and lower levels of the satiety hormone leptin. Now, if you've been paying attention, you know that is a combination of hormones that can lead to overeating. And the effects compound because being stressed and sleep deprived can also lead to you feeling more fatigued and less motivated to engage in healthy habits like going out for a run or meal prepping. And remember too that managing stress doesn't mean that you have to figure everything out by yourself. It could also mean doing something like finding a support group or even meeting with a therapist. And that leads me to the last thing that I want to highlight. Make sure that you are not neglecting exercise. Exercise helps us to maintain weight loss via several mechanisms. For one, it can improve leptin sensitivity, which translates to more satiation and less of a desire to eat. It can also help with fat burning, the preservation of muscle mass, and it can help to reduce chronic inflammation. Research shows that for people who have been on a weight loss journey, exercising makes it more likely that they will maintain their new body weight. And that brings me to the end of today's video. Thank you so much for watching. If you learned anything new or think that people can benefit from this information, please share the video far and wide, like, comment, and subscribe for more content like this. If you would prefer to read the nutrition information that I cover on this channel, please feel free to check out my blog as well. Every video that I make on YouTube, I turn it into a blog post so you can go there for reference, or again, if you just prefer reading, it's there for you. I will link it in the description as well. Take care.